Hey guys, welcome back to the channel. So today I thought I'd bring you along. I'm doing a little bit of wiring for the Whole House Humidifier at the furnace. Yeah, I figured I'd try to explain this to you guys. So if you've seen my other videos, you'll know that over in the utility room off the hot water tank, I ran a hot and cold line basically that runs all the way over to my furnace to supply my whole house AprilAire humidifier with hot water all the time. And you know, it's recommended to use hot water. I don't think you have to with the model I have because it has its own fan built in, but it's recommended that you do. And you know, I already ran all the PECs and everything to make that happen. So what I want though is I want to wire this up with a relay so that the pump, it's a stainless steel Taco 006 pump that I have over there at the furnace. It's mounted right behind it, and all that pump's going to do is just bring hot water from the tank to the furnace and then put it back to the tank. So it's basically like a little recirculation loop. But I don't want that running all the time. Obviously, it wouldn't be very efficient. I'd be constantly stealing heat from the hot water tank. So then I thought, okay, well, I could have it running only when the heat's on, but even then in the winter, that's not really very efficient either, because if the house doesn't need humidity and the whole house humidifier isn't on, then there's no sense in wasting the hot water to dump over there. So what I came up with was I got another one of my little iDeck RH1B relays here. This is a 24 volt relay. So what I'm going to do is this is kind of what I came up with here. So I've got my furnace, which is 24 volts, and there's a lot more wires going up to my thermostat, but for the purposes of the whole house humidifier, there's a hot and a common. Okay, and the Ecobee thermostat is what is measuring the humidity throughout the house, and that's what's turning on or off the AprilAire whole house humidifier. Okay, so it's very simple. So all I'm going to do is tap off of the hot and the common, or the neutral, going to the whole house humidifier, and go into terminals 13 and 14 on this relay. Okay, and what that'll do is anytime the thermostat decides that the humidity in the house is too low and that the humidifier needs to run, it will energize this loop, which will turn on this. And in the meantime, because I'm tapped onto it here, it will energize my relay. So then what's going to happen is, coming from a 120 volt switch that I have here, the hot will come down and pass through the two outside terminals here. Okay, so I think one of these is terminal 9. I forget the number on the other one. But then, so whenever 24 volts is sensed on this side, this will close, and 120 volts will be passed directly to the pump. So that'll run the pump. So as soon as the thermostat determines that humidity is needed, the pump will come on and bring hot water right up, you know, within, I'll show you guys, but within like, you know, 6 inches of the humidifier, I'll have 140 degree water right from the tank. So it should do very well. Okay, now if you look here, you know, obviously the neutrals pass directly through to the pump, but what I'm also going to do is on the other outlet here, I'm going to come off and I'm going to use another one of my SmartThings smart switches and also have that wire directly to the pump. So what that'll do is, in the off season, like the summertime, or you know, on a rotating basis, I mean, I could have it come on. With this, I can program it in SmartThings to do whatever I want. So, you know, we can just say that in the summertime, or just year round at midnight, run this pump for 60 seconds. And all that'll do is it'll allow the pump to run just to purge that water that's in that loop. It is kind of a longer loop from the back of my house where the utility room is all the way up to the furnace. So, you know, on a regular interval, that'll just run regardless of whether the house needs humidity or not. It'll just run the pump so that the water in that 1/2-inch PEX line doesn't get stagnant and nasty. It just constantly gets flushed out with 140-degree water from the tank. So I purchased one of these these boxes here. I think I got it on Amazon, and I've started to kind of wire it up here. So I have my power. This is going to be my 120 volts that's going to plug in. It's going to be that top outlet. And here I've got my ground, my neutral, and my hot. Okay, so I will wire the hot right into terminal 9 on this relay. And the ground and the neutral will just pass through, so they'll just continue on through to the pump. Then these are going to be my 2 wires coming in from the furnace, which I've got a loop here. I'll run over to the control board in the furnace and jump where it comes down from the thermostat. So I've got all this in here. I'm just going to wire it up, clean it up, make it look nice. I also might make the other connection out to the pump, because what I did with the pump is I hardwired in like a computer cable that I had laying around, you know, something like this. And I can take you over there and show you, but to terminate all that in a box, I might actually bring that in here as well and make all the terminations in here. So I'll need another 120 volt plug that goes into the smart switch that will then, instead of going directly to the pump, it will, but it'll come into this box and make all those connections in here inside the box. So, and I can use some of these little DIN rail accessory terminals here, to do all that, to keep it nice. Or I could just just use regular wire nuts, and it'll all be in a box. It's covered and mounted over there at the furnace. So the other thing I thought about doing was, I do have one switch left here from my if you've seen my electrical system overview video on how I wired the snow melt and the tankless hot water heaters. I think I'm going to put a switch in the front of this box so that if I want to, I can walk up to it manually and turn it on, even though the smart switch has a button on it, which I could do that too. But I'm thinking I'm going to incorporate this switch into the system somehow. Probably, I might even just do it just to bypass this and run the pump like right there if I want to, even though I mean it's probably redundant, because like I said, the smart switch itself has a button on it where you can just turn it on manually and turn it off. But I could also have to think about this. I could also maybe put it on the low voltage side and turn on the whole thing, jump this out, turn on the whole system. It would have to be before the thermostat. So anyway, yeah, I'm still trying to figure that out, what I want to do there with that, but I'm probably going to just put that switch in here, wire this all up, and mount it over at the furnace, and I'll try to set the camera up and just show you guys what I'm doing as I'm doing it. I might even set the camera up here and just show you, maybe do a time lapse or a quick video on how I'm wiring it and everything, just to see. Usually my videos are kind of a before and after, but I'll try to bring you along in this one. And then I've got some more plumbing to do over there. The humidifier was hooked up before, and it drains into the condensate drain that goes into the drain tile in the basement floor, but I didn't like how it was pitched, so I'm going to redo the plastic for that. So here, let me take you over there and show you what I'm talking about. Alright, so we're over here at the furnace. Hopefully this is bright enough where you guys can see this. But here's my hot red PEX line that comes in. It runs all the way down this beam, all the way to the utility room. Comes in down here. It has a tap off of it that feeds directly into the valve that will open and close with 24 volts that goes to the furnace. So here's my control, my 24 volt control wires coming from the furnace right there. They're red and blue, so I'll tap into those. The furnace gets its power already, or the humidifier gets its power already from the 120 volts. It's hardwired into the furnace, so that's fine. My hot line then runs over. Hopefully you guys can see this. I'll get some lights when I set this up, and it goes to a Taco 006 pump that I just mounted on the wall back there, and it goes up into a blue cold. You know, I had the PEX laying around, so the hot was blue, and then going back it was cold. So what I did here was it turns and runs back to the utility room there, and it also tees and comes over here where it comes down in, and this will all be propped up and secured nicely and everything. And then I have a valve where I can open this up and flush the line, and it goes right into the floor over to the drain tile into the sump pump. So I can flush the line, I can purge the line, and do all that. So here's the whip I installed on the pump. Here's the pump. I put my little LED in there so I can tell when it's on, and then I just took a you know, the end of a really light gauge computer power wire, and so this will run into the box. I'm going to mount the box right up here on the sheet metal, and then right behind it there is my 120 volt outlet. So it's a GFI because we're dealing with the water here, and I don't want to you know, risk any shocks or anything like that. So the plug on the back there will be my 120 volt that goes to power the relay that I already explained. Okay, so then that will turn on, and it'll pull 120 volts from that outlet whenever the 24 volts going to the humidifier is on. And then I'll also have in my little smart switch here, and this is what I was talking about with the button where you can just turn it on and off. This is a Samsung SmartThings outlet. This will go in and also just be hardwired right to the pump. So I can set up a schedule in SmartThings that says, you know, every day, every other day for a period of however long I want, run this thing and just purge the water that's sitting in this line, you know, so it doesn't get nasty, especially in the summer when it's sitting for months. So anyway, yeah, that's what I'm going to work on. We'll see if we can get this wired. I'll try to maybe stick you guys over here. This is the old AprilAire controller that came with the unit. Ever since I got the Ecobee thermostat, I really don't use this anymore because the Ecobee has its own humidistat in it and can sense the humidity upstairs and throughout the house. So I think it does a little better job. The other thing too is this sensor, or this sensor or controller, requires an outdoor thermostat on the house if you want to do like an outdoor reset, because the colder it gets, the less humidity you really want to be, you know, pumping into the house. You're going to end up with frost on the windows and that sort of stuff going on. So, you know, this unit did come with an outdoor sensor, which I had mounted for a short period of time. Then it stopped working, and you know, it's all manual, so you kind of got to set it, and then you know it will handle itself. But you know, anyway, what I might do is just provide power to it just so it can get a humidity reading, just so I can see what it is down here, but it's not going to control anything. The Ecobee connects to your local weather station for your area, and it knows what the outdoor temperature is, and it has like a frost proof setting on it. So as the temperature drops, the Ecobee knows that because it's internet connected, and it will automatically adjust the amount of humidity that it's putting into the house. At least that's my understanding of it. We'll see how well it works this winter once all this is hooked up, and we'll go from there. The other thing I've got to do is I'm going to cut into this line here and put a spring-loaded check valve in, because what I realized was happening was I was getting ghost flow by just leaving this all open. That's why that valve right there is closed. Just leaving this open, the natural movement of hot water, the hot water is coming out of the tank and rising up through the 1/2-inch PEX all the way down here, you know, 30 feet away from the utility room, cooling and then getting pulled back to the tank all on its own with the pump off. So, you know, and there is no flow check inside that pump, at least not that model. So I just bought a cheap, you know, PEX spring-loaded one. I'll cut that, drain it, crimp that in there, and refill everything and wire it up, and we should be good to go. That should stop the ghost flow, but the pump will have enough head to pull open that check valve, and we should get the, you know, but when it's off, there will be no hot. I'm not constantly losing hot water to this loop at all hours of the day and night when it's not needed. So yeah, I noticed shortly after I installed the whole system that this line was hot like all the time. And it's like, wow, you know, it's not on. It's not even wired yet. So it's just flowing on its own due to, you know, what do they call it? The natural convection of hot water, or there's a term for it. But anyway, yeah, let's work on this and show you guys what I do. Okay, guys. So one thing that we need to confirm here is which of these wires goes to which prong, and I'll show you how to do that just with a simple multimeter, just testing for continuity. But first, you kind of need to know on a standard US outlet which prong is your hot, which is your neutral, and which is your ground, right? So what I did was, real quick here, I set up my voltmeter. Okay, and I'm into, if you were looking at this, the one on the left, and I'm going to take the other end here and put it into the ground, and you're going to see that we basically have nothing. Okay, so the one on the left is your neutral. Now I'm going to take this and put it into the other side here, the hot, the one on the right, and you're going to see, see this, but you're going to see that we have 122 volts here. Okay, I removed that. We're good. Now the other thing we could do here is we could take either one of these leads, it doesn't matter, and go into the hot blade and go to the ground, the bottom prong. We're still getting 120 volts. Okay, so we know, looking at an outlet, the one on the right is our hot. Okay, so now what we're going to do is we're going to come over here to the bench, and we're going to set our meter to continuity here, and leave the mode. We'll get that little symbol that looks like that, which will give us tones when we have continuity. Okay, so I'm going to put that to my one on the right, which I know is hot, and I'm going to come over here and I'm going to touch these wires. Okay, so right there, brown is my hot, because brown is the one on my right. Okay, now obviously it's hard to do this with one hand. I should have the mount on my head or something here. I'm going to try to set it up on this tripod here for you guys. Maybe this will help be moving around so much too. So the other thing I can just test, I mean, we kind of know at this point, but I'll touch the one on the right here, and we'll go to the blue over here. Yep, so blue is our neutral, and obviously, I think I kind of knew this before we even started, green should be our ground. And it is, okay? So now that we know what we need to wire here, brown is my 120 volt hot wire that we are going to interrupt with the relay. Okay, so I kind of had a feeling it was, but it's always good to check, because you don't, I mean, you could, it really wouldn't hurt anything. You'd be kind of breaking the neutral instead of the hot, but you know, you definitely don't want to get things crossed where you've got a hot coming in and neutral coming out, and you know, it's how you end up making smoke and blowing stuff up. So yeah, we'll bring this hot into one end of the relay, we'll take another hot that goes out to the pump, wire up the 24 volt, and we're good to go. But I just thought I'd show you, if you guys weren't familiar with figuring that out. That's how I figure it out. Okay, so here's where I'm at. I got my power coming in here, wired in. The hot goes into terminal 9 there at the top. If you guys can see that, I also got my two 24-volt wires wired into terminals 13 and 14. I have my ground going to this block and my neutral going to this block, and those are just going to pass through and go out. I pulled the relay off. That's the cool thing about these rib relays is, you know, if one of them goes bad, you just pull it out and replace it. You don't have to rewire anything. I have a good friend of mine who owns a car wash who taught me about these things, and I've never gone back ever since. They're great. Now you do have to pay attention to the voltage rating on them. These ones are, I don't know if you can see that, it says AC 24 volt on there. You got to get the right voltage, but as you can see, you know, I've got some 24 volts. I used all 120 volt ones. These are all spare 120 volt ones over at the water heater setup over there. So, but yeah, so here's where we're at. So now what I'm going to do is wire in this. This is going to be my smart switch plug, and that's going to come in, and that's going to tie into basically all of the outputs along with the wire to the pump. Now the whip to the pump is already installed over there, so I can't pre-wire that. So I'll have to do that on the furnace over there to bring that in and hook all that up. Then all we have to do is cut this to length and wire nut the red and the blue in with the red and blue that are over there, and we should be good to go. But I'll set the camera up over there when I wire it in finally and let it run. It's hard here because I don't really have a way to mount it, and but you know, just coming back and showing you guys what I'm doing. So anyway, that's where I'm at. Come back in a bit. Okay guys, one thing I forgot to mention on these relays is they can be wired one of two ways. So if you notice here on my drawing, there's a normally NC and NO, okay, and that's normally closed or normally open. And what that means is you can wire it so that when the 24 volt side of the relay is energized, the opposite side either opens or closes. So in this case, I want this when the 24 volt side is not energized, I want the relay to be open. I do not want power going through to the pump. Okay, so I want mine normally open. Now you could have it so that when the 24 volt side was energized, it turned off something, like a light or whatever. In my case, I want it to turn on something, but you can wire that either way, and the only difference is what terminal you put your output on down here, either 1 or 5. Okay, so in my case, I want it normally open, and when the Ecobee thermostat turns on the Whole House Humidifier, I want the relay to close and provide power through the relay to the pump. Okay, so I'm going to wire mine on the lower terminal, terminal number 5, for normally open, which is where I'm going to connect this brown wire right here and all the wires that go out to the pump. So right now, these 3 wires are coming in from my other switch, which I'll be used to turn on at a certain time of day for a certain period of time. If you're wondering, what happens if this one is on and this one is on? Nothing. You're still only getting 120 volts through everything to the pump. So the pump will see no difference, even if it's being energized from both, you know, this side and the side coming in from the smart switch. It's no big deal. You can do that as long as you're on the same side of the pole of the breaker box, you know. So as long as you're on the same outlet that's wired to the same breaker, that's all on the same side, you're only pulling 120 volts from one leg of your feed coming into your house. Now, got to be careful there with, you know, if for some reason you have 2 different power sources coming into one box, and say each outlet is on a different side of your panel, then yes, you could actually have 240 come in here, and as soon as the second one came on, if the first one was already on, you're going to put 240 to that pump and blow it up. Okay, so hopefully that makes sense. As long as you're on the, you know, the same breaker, same outlet, you know, in this case I am, it's all the same thing. It's no big deal. You can pull 120 volts from however many sources you want, and as long as one of them's on, you're going to get power to, you know, everything, and that's not a problem. It's when you start crossing, you know, you get into the 240 stuff is when you can really start to get in trouble. And then just for those of you that are asking too, or that we're going to ask, I did check these as well, like I showed you with the voltmeter. Brown is the hot. I wouldn't always assume that though. I've noticed doing this, you know, I'm using just these things were actually in the garbage. I was gonna, we were gonna throw them out. They're just computer power cables for monitors and printers and old stuff I've had laying around here over the years, you know, and I save them and then I use them for stuff like this. But you know, these manufacturers are all different. Half of them are from China, and some use way different color schemes than others. So don't always assume that, oh yeah, well it's brown, blue, and green. Brown's my hot. You know, I would double check that, because if not, say for some reason this particular cable manufacturer reversed them or something, now you've got a neutral that you are about to wire to a hot. Okay, and vice versa here. You're about to bring a hot in with a neutral, and as soon as you plug this thing in, it's gonna pop. It'll probably blow the breaker. You'll probably blow one of these DIN blocks, and you're gonna wonder what the heck happened. And it's because you basically just gave 120 volts a direct path to neutral or ground because you didn't check to make sure that the polarity of the wires are okay. So just thought I'd mention that too. You know, double check yourself, be safe. Check your continuity, make sure that what you want to do is what you know, what you're expecting to do here. So, all right, be back in a bit. Sorry, the lighting's not the greatest over here. All right, so this is my wire for my pump, and I want to bring that inside this box. So let's cut a good amount off, cut it off here. Okay, the power is on to the furnace and everything right now. This outlet shares power with the furnace, but this switch is off, and I haven't plugged in the one that's hot all the time. I could, because it just goes to those top 3 contacts, which I'm not going to be anywhere near, but I'm just gonna leave it. I might even, you know what, for now I'll just unplug this too, just to be safe for YouTube here. So I was gonna put that switch in here, and I didn't like the terminal on the back of it. It was kind of loose, so I don't really want to use that one. I'll have to order another switch. And what I think I'm gonna do for that is I'll actually bring the pump wiring into that switch, so that no matter what is on or off, it just be a fast way to come down here and shut the pump off. So I won't mess with any of the wires coming in from the smart switch or the 120 volt. Basically, I'll just interrupt the power going out to the pump, and that way if I come down here and something's going on and I don't, you know, have my phone to or whatever to shut that off, right, or say there's water spraying everywhere and I really don't want to reach back here and risk getting shocked or something to turn it off, I can just flip that. The pump will turn off. I'll still have power to the box, but the box should be waterproof, so be the end of the world. But that should give me enough room to rewire it if I ever need to, if this pump fails. Just make a little mark on that right there. Pull it back out. This razor blade is not the sharpest. get some better tools. Sorry guys, forgot to turn the camera back on there. So I got that wire in. Just prepping it now for, I'm gonna leave. So the ground can go right into that ground there. Cut that off right about there. Strip it. Yeah. Oops, sorry. Bumping the camera. I'll go a little bit more than that. Alright. Hopefully you guys can see this. Let me see if I can move this light somehow to how can I do this to show you guys what's going on here? This thing is just not gonna stay where I want it to stay. Well, let's try maybe propping it up here like this, I guess. There, is that better? Will that stay? We'll try it. Hopefully that's a little better. So, green is my ground. I'm going to put it up into that output there with that one. Get my little screwdriver. Right here, and we will tighten that down. Hopefully you guys can see this. Alright, both of those should be good and tight, which they are. White is our neutral. We're going to do the same thing. We'll cut it right about there. Strip it out. We'll give it a good, I don't know, 1/4 inch. A little bit less than that. Should be pretty good. And we're going to share that neutral output with this. This is a lighter gauge wire that goes out to this pump. Should be fine. I mean, you know, if you look at the rating on that motor plate, this pump is 0.52 amps, which is, I mean, it's not nothing, but it's practically nothing. You know, you don't need 12 and 14 gauge wire to run a little pump like this. It just doesn't use the energy. So now what I'll do is onto this bottom terminal here, my normally open terminal. I'm going to leave this long because my plan is eventually to put that switch in, and I'll run this up to the output of the switch, and then I'll run the power from here up and into that output as well. So basically, you'll have to think about that, but basically my power going out to my pump will be interrupted by all of the inputs coming from the switch. So either that one or that one, if it's open, will go up to the in of the switch, and then the out of the switch will go to the pump. That way I can kill the pump no matter whichever one of the two outlets is on. I'll be able to kill the pump if I need to, or just leave it off permanently, no matter if the smart switch is trying to turn it on or what. Now this one I did tighten down, I do believe. So again, we'll leave this long. Sneak into the other side of it. If I can get this thing, that's a mess. Okay. So now we'll just double check that everything's tight. It's tight, tight, it's tight. This grounding DIN block here also grounds the bar too, the way it clamps internally, and then there's these covers that you put over it. So you guys are seeing this. These covers that prevent the sides from showing, so if anything were to rub up against, you know, the side of one of these, wouldn't cause an issue. This is there's nothing hot over here anyway. The only hot stuff is basically here. So I think we're good. Let's plug in the power that's on all the time. Actually, we still have to do our 24 volt wiring. Okay, there's that. There's that. So let's get our multimeter. We'll set this for AC. I'll try to put it somewhere where you guys can see it. Let's see if you can see that. Alright, so right now we want to go ground to hot. We have 121.2 volts there. Okay, what about the other side right now? Nothing. Okay, and that's because that's normally open. We don't have the relay in here yet either, but so we do have hot coming in the top there. We should be able to hit this screw and check. Yep. So our neutral's good. Our ground is good. Okay, now down here right now we should have nothing, which we just checked, right? Okay, now what if I turn on the smart switch? The pump is on because it's providing power to the pump, which is exactly what I want. So as soon as I turned on that switch, it energized this terminal, which goes out to the pump. I don't want to turn it on right now because it's deadheading. I've got it off, but it did come on, so we're in good shape. This is wired exactly how I want it to. I will put the switch in, I gotta order that. But let's throw the relay in it, and we'll wire up the 24 volt side. Okay, here's my 24 volt AC relay, which I talked about. You know, you gotta pay attention to these. So we will put that in. Okay, so we should be good in that box. I'll leave the cover off it for now, but now what we need to do is down below here. You guys, here you can see it. There's these two wires right here that I basically need to just tap in the wires from the relay. And that'll give us our signal when to close that relay and when to turn on the pump. So let's go ahead and cut this right now. Rid of that extra wire, and then just find a neat way to run this. I'll probably end up zip tying all this down over here, but eventually. But for now, it's just, we'll go something like that. This is just thermostat wire. And we will strip that open, and we're really only looking for the red and the blue. I think there's there's 4. This is 4 wire, I do believe. But we don't need all that, so strip this casing back. I could try to move the light down here so you guys can see a little bit more of what I'm doing here. Let's strip this wire off here. Okay. We only want our red, so this is 5 wire. we'll just cut these other ones off. I would normally just fold them back and leave them, but it's such a short run and it's easy to change. You know, normally you would leave these extra ones just kind of coiled up around the base in case you ever need a wire goes bad or something, but this is pretty easy to get to, and if that were to ever happen, I can just replace that little, you know, it's like 2 feet of wire. So my strippers here. This is, I don't even know if this is 18 gauge. Yeah, it looks like it. Okay. And then we can actually test it. I did solder those. I like to usually solder my stuff. There's even a warning here on the thing that says don't connect these to line voltage. They're obviously 24 volt. You connect them to line voltage, you're gonna blow up the humidifier. So I could solder that. I might still, but for right now, we're gonna leave it like that. Take off the neutral, or the common, I believe it's called, and 24 volt land, and okay. So all we did there was tap into our low voltage. So whenever that comes on, it'll run the pump. Okay guys, so here's what I'm gonna do. First, this tank is getting ready to kick off, so I'm gonna shut that off because I don't want the heaters to turn on while I'm doing this. Right back here, so this is my output off my tank, okay? It comes back here and it splits and it goes down to the 3-way mixing valve, and it also turns right and goes into that red pipe right here, which I'm going to open up. So that's open now. That goes to the humidifier and comes back on the blue. Okay, and that's down at the bottom there. Now there's a 1-way check valve there, so the flow can only go this way. It cannot go back. So it can dump into here, into this neutral area here. Can't go back that way. This is where my cold water comes in. Can't go back this way because this is where the return comes from the Recirc. So it can either go up through the heat exchanger, through the heaters, and back into the tank, or it can go into the tank. Now, what I'm going to do is I'm going to open this up, which is going to start allowing cold water to come in and out. Then what I'm going to do is, from my phone, I'm going to turn on that pump now that we've got it all wired. So I'm going to have the SmartThings app here, and what that's going to do is it's going to start pumping through this circle. It's going to go out and start coming back. So all that water that's been sitting in there for a couple of months hasn't really circulated. I don't want that going into the tank. It'll come out, mix with whatever's coming in from the street, go right out the hose. We'll flush it, we'll let it run for a few minutes. It's just dumping right into the sump pump, and you know, we'll just let it flush. I mean, we're gonna waste some water, but that's okay. I think it'll be good to get it flushed out. So let's head back over to the furnace and make sure we're all good over there, and then we'll clean this out, and then we can play with turning it on and off and seeing if it works with the thermostat and everything. Alright, we're back over here at the furnace, and I'm going to leave that valve closed for a second. What I want to do real quick is I'm also going to close this valve here because I do not have the drain hooked up for that yet. I talked about it earlier. I've got to reroute that around and empty it into, tee it into here for the condensate. So I also got to put that, cut that and put that valve on and stuff. But for now, I just kind of want to give this a quick purge. So I just want to make sure on my phone that I have it working. So I go to the hydronics section of my app here, and the humidifier pump, when I hit that, this should turn on, which it does. Okay, now it's deadheading right now because I have the input closed. So what I'm going to do is I'm going to open this up. Open. Okay, now we should get flow through there. We're closed over here. We're going to go over to the heaters. All right, so we're back at the heaters. I've got the tank off. I've got the recirc pump off. So nothing else should kick off here. Let's go ahead and open this up here. Okay, and let's turn that pump on. And it's on. So I should know as soon as this starts getting hot coming back, because it should be hot going out. Oh yeah, it's getting hot going out. So how are we doing coming back here on this line? Alright, we're gonna shut it. I'm gonna shut that off for right now. Some pump gets a little airlocked sometimes, and it eventually will purge. But it runs for a second. There it goes. Now I'm sure that hit my sensor, so we'll shut that pump off. Now I'm sure I just lowered the temperature of the tank by doing that, although we're still showing it's at 125. So, and this is really hot coming back right now, this line. So we'll give it another little run here. Turn that on. And we'll open this up. Just give it a good flush, you know. Alright, sump pump's running. It's hot. This is cool. Alright, we'll shut this back off here. Turn this off. Alright, we're back over here at the furnace, and this line is nice and hot. Oh yeah, there's hot water in there for sure. There's hot water up there heading back. This shouldn't really be, no, this is cool, so that's good. Now if we did open this, we should get some hot water from the tank. Yep. Okay, that's nice and hot, so we purge that. So I'm pretty happy with that. The line should be clean now, so let's run back over and just run the tank, just so that if there was anything in that line, I doubt it, but okay, so back here in the utility room, let's just run the tank. It's down anyway. It's got to have lost some heat from doing that. So I'm going to turn the tank aquastat back on and let the heaters run. Yep, 122, so we're definitely below 126. So they're gonna fire. Okay, looking good there. We'll turn the Recirc pump back on here. Power to that aquastat. And then, yeah, it's dropping 120. So this is going to run for a few minutes. Let's go ahead and just, let's run that pump. I'm going to run that humidifier pump for a few minutes and going to let it really flush through while this water's being heated. So let's go back over there and check for leaks and stuff. We're definitely circulating really hot water through here. It feels nice and hot. So that'll be nice. Once this valve is on, it's gonna pull that 140 degree water right from this slot loop right into the humidifier through this little 1/4 inch tube here. So the humidifier will get the hottest water it can get, 140 right from the tank. So, which is great. That's what they recommend. The hotter the better. And I'll work on the drain here, and then this is done. We're ready for winter here to use this. So that's running, no leaks. Nothing's leaking. I've had water in it all along, so I knew it wasn't leaking, but always good to check after you've purged it. So we'll turn that off. And we'll go back over and check on the heaters. Alright, back over here. We're up to 128. And if we wanted to, we could open this hot water valve here. Can hear the heaters ramping up. So we'll let that so it's already kicked off. The tank's already kicked off. That sump pump there lost its purge again. It does that every now and then. It does recover though. Oh, there it goes. And the heaters are already off and we're good. So pretty confident there's nothing, you know, anything. I mean, the water's good. It's not like it's been sitting in here for years, and it is city water. So really, you know, in order to get like bacteria, it's got to come from somewhere, and the system's been closed. So, you know, I'm confident that the water that was in there is now, you know, just went through the heaters at 140 degrees and is back in the tank. So we gave it a good flush, so we should be okay there. Let's test and see if we can turn it on with the Ecobee. Alright, gonna prop you guys up here. I'm gonna go up and put the thermostat into installation. There's like a test where you can test all your equipment, so I'm going to test the humidifier. So you'll probably hear the fan come on this thing, but this relay should also click and the pump should come on. So I'll let this roll and I'll run up there and we'll see if it does it. Okay, humidifier is running, I can feel it. there's no water getting into it because I have that shut off. But the pump came on. Perfect. Okay, I'll go turn it off. Okay guys, it works. So, yeah, it's exactly what we wanted to happen. Whenever the furnace, or the thermostat I should say, determines that the house needs more humidity in the winter, it will fire the whole house humidifier, which will in turn fire that pump, which will bring the hottest 140 degree water from the tank right to here. Which will go into the humidifier. It'll go out through the condensate line and down after it like goes up top, and it goes over like a filter in there, which I have a couple of those filters over on the table over there. But yeah, so now all I need to do is plumb in the drain here and we're good to go. I'll put the cover on this. I did order a few minutes ago more switches, so I will probably come back and just unhook that hot wire going to the pump and hook it to the bottom of the switch, and then run a jumper that goes to the bottom of that relay. And that way I can always shut the pump off, even if the humidifier's on, or even if the Smart Things is on. It won't matter, the pump won't run. It's just a quick safety I can put in here if I want to just keep the pump off for whatever reason. So I'm gonna do some plumbing now. I might bring you guys back for that. I don't know, this is probably getting really long with all the wiring and everything, but I do have to purge all this again. I'm gonna shut this off and shut that off, cut this line, which is gonna drain this hot side of it anyway, crimp in the spring-loaded check valve, because right now I'm sure it's ghost cycling, which makes the heaters run a lot more often, because this loop is just constantly stealing heat from the tank. So I'll shut that off over there on that end at the tank like I had it off. Cut this open, drain all this water somewhere, crimp that in. I'll work on the drains, PVC drains. It's pretty easy stuff. And then I should be able to just open up this and open up those two valves, and it'll purge this hot loop up and out and down the drain. The water won't come back this way because there's a check valve on the other end that won't let it come back this way. So hopefully we'll get a lot of the air that I introduce into the loop when I cut this open. We'll get all that out before we even open it back up to everything over there, you know, so none of that air makes its way back to the tank would be ideal. I'll already have the flow running, so if that's already open when I go to open this, the water and the air is definitely going to want to turn left and head that way. So that's my plan. See if we can get this wrapped up, and maybe I'll bring you back and show you the end here. But thanks for hanging out and doing some wiring and working on the hot water system here. It's kind of fun. Thanks guys. Alright, one last update here on this one, guys. So I got the spring-loaded check valve installed down here. I put a Tupperware container underneath it and put a towel down and draped a towel over it. I shut it off here before the pump, and I also shut it off back at the heaters next to the tank there, so there's no more water pressure being applied to this loop. When I cut it, a little bit came out, very little dripped. It all went into the bucket, no mess at all. I cut it back and then just crimped in that check valve. These are directional, they do have an arrow on them. I don't know if you guys can see that arrow on there, but I wrote a bigger arrow on the bottom of it so that I could I didn't screw it up, but yeah, it seems to be working fine. So I just purged all the air out by opening it up over at the heater, and then as I opened up this valve, I also opened up this valve, which purges everything this way. And real quick, got all the air out. I ran the pump, the heaters were just running, so I manually fired up the pump with the SmartThings switch there, and let it purge again, let it flush again. Any air that was left or anything else in the lines would be pushed back to the tank, and we're good to go. We're in business. So my next thing to do here is to get this drain finished up. Was planning on doing that today, but I'm all out of 3/4 inch PVC, so I need to run to Home Depot and pick up some more PVC. Or I thought about maybe just using the clear stuff. I was going to do a short section of clear and then transition to the PVC, just you know, just because I like to see if it's plugged or anything. If it's backing up, it's easy to see when it's inside the clear tubing. Maybe I just run clear tubing all the way down around and tie it in down there. I might actually do that. Just put a T in down here. That way I can see the whole line. I can see if it's getting plugged with garbage or whatever. And yeah, I'm actually thinking that might be a better way to go. So I'm going to think about that. Yeah. So anyway, I would call this a success for now, and I'm going to program that smart switch up there. Probably once I sit down tonight, I'll log in and set this on a schedule. So, I'll set this on a schedule to come on and just circulate, you know, for, I don't know, probably only needs to be 30 seconds once a day. It really doesn't take long to purge, to cycle that whole line. It's only 1/2 inch. There's not much water in it, so 30 seconds is more than enough to give it a flush. And if I did that, you know, once a day, I think we'd be fine. In the winter, I doubt I'll even have to worry about it, because this is going to be on and it's going to be purging itself. But yeah, anyway, so the whole point of this was, number one, to get the hottest of the hot water right to the humidifier, which we've done. This is 140 degree water through here. It's before the 3-way mixing valve, so it's getting exactly what the tank temperature is, which coming out of those heaters is 140, so it should be getting something close to that. And the other purpose of this was to put this pump in to purge the lines when well, the pump, you know, brings hot water here, but also the smart switch and the relay and everything to fire this off, fire the pump off when the heater's on, and also to be able to purge it in the off season or even during the winter, you know, to be able to flush it. So yeah, I'm gonna call this one a success for today. I'll might come back and do another one when I add that switch. I don't know, it's pretty easy. I don't know if you guys would be interested in seeing that, but yeah, that's really all that needs to be done, is the drain and the switch, and this is completely done. So another item checked off the list. So anyway, thanks for hanging out, you know, for a few hours here while I putzed around with this, and we got it going and working. So, and hopefully you learned something about those iDeck relays. I really like those. So thanks for watching. We'll catch you next time.